Hey there, and welcome back to the afternoon of API Days Live Paris. My name's Mark Boyd. I'm the director of Platformable, and I use the pronouns he and him. I'll be your MC for the rest of the afternoon, where we're going to focus on APIs and data architecture. Our first speaker is David from Botify, who'll be joining us now. Hey, David.
Hey, Mark.
Great to have you here. Thanks for starting this afternoon's talks. We'll be focusing on data architecture. So what better than a talk about building an analytics API? David,
Right.
your slide work seems to be fine, so I'll let you get into it.
Okay, perfect. Well, thanks a lot, Mark, for the introduction. And yeah, let's start right off. And thanks for being here and listening to me. Let's talk about analytics and the data behind it and the APIs. So just very quickly, I'm David. I live in Paris. That's pretty nice. Last time I had an API Days conference, it was at 2 during the night for me. So now it's in 3 p.m. That's pretty cool. I'm a lead engineer at Botify. We're going to talk a little bit about the company to get some context and understand what we will be talking about. And yeah, I work a little bit around APIs. If you want to connect, there are some links down there. You'll see the slide afterwards. Don't hesitate to send me any question if you have some. So let's jump right into it. What we're going to talk about today to build an analytics API is, first of all, define what I mean by analytics, get the base ground first. Then we're going to talk about the use case that we're trying to solve here and trying to understand what's the perspective here, what we're trying to do. Let's talk about architecture, since this is the data architecture track. And finally, the lessons we learned during this journey while building this analytics API. So first off, the definitions. I'm going to start with the basics, which is what's relational data compared to analytics data. So what's often called relational data is often the most used databases, the relational databases like MySQL or PostgreSQL. This data is often structured. We have tables with columns. We know what values are in these columns. Can it be nullable or not? What types do we have, etc. There are also constraints, which we just saw, and the data will be normalized. When you have duplicated values, we actually take the data out to another table and you link them together through some foreign keys, for instance, or any relationships that you can have there. So that's what's called OLTP, online transaction processing. So you have transactions, you have a certain consistency model, you know that when you update, create data, delete it, you know it's there, you know it's worked, or it will be rolled back. So that's pretty nice. It's used a lot for building web applications, and it's pretty efficient to access specific rows in your database if you have it indexed. Then you have analytical data, or it's often the SQL against NoSQL. So analytical data will often be not necessarily structured or less structured. You will have less constraints. You don't always have the same things that you expect in the database. And what's called OLAP, so online analytical processing. So you will basically have a huge data set which you don't exactly know what's in there, and you'll be able to analyze it, to look at it in any direction. It's sometimes called a data cube, so you will aggregate in all the different directions, dimensions you have in metrics to see what you can do with that. So when talking about APIs and web APIs, we'll often think REST APIs. Those map pretty well the relational databases, right? You identify your resource. For instance, you're going to use my API / users to get your user, which maps a table in your database. You will also get hyperlinks, which basically follow these relationship constraints you have in the database and going to fetch other tables, like, for instance, the projects related to a user. And then you have methods that will alter the resources. It will generate different SQL statements, create, insert, delete, whatever. And you often use the HTTP verbs to represent these methods to alter resources, to do your CRUD operations. So this is the mainly used database for modern web applications. Now, what about analytics? How would we want to do that in a web application, for instance? How would we query data from analytics? Well, you could have also REST API, but how you don't have necessarily one resource, since you don't know what resources are available, since that is very heterogeneous in your analytical database. And also in search and update deletions, all these modification operations will happen from other sources. You might have, for instance, your website is sending events which are tracking the user, and these events are pushed into this analytics database. So lots of different events, hundreds of inserts that are streamed to the database. So this won't happen directly from the application itself, but maybe some batch processing behind it. So the question here we want to tackle is, if you don't have these resources, foreign keys maybe, how do you define REST API using analytics, since there are so many use cases that you want to be able to express? And so we're going to have to understand what's the use case we want to express exactly, so that we know how to build around it. So a little bit of context about the company, about Botify. So we're doing search engine optimization, SEO. And in very technical terms, we are basically ingesting data from a lot of different sources. This data is very, very huge and has lots of different metrics. Then we allow filtering, joining, aggregating that data, and we provide insights around it. That's in very technical terms what we do. We're going to see a small example. We're going to basically show our users a snapshot of their website. What does their website look like? How is it performing on Google, etc., to be first on Google? Because that's the goal in the end of SEO, is when someone searches something, you are nicely ranked inside of the Google page results. So for instance, we're going to crawl web pages. So we're going to analyze the website of our customer. We're going to get their log files like Apache. We're going to fetch events from Google Analytics. We're going to see the keywords thanks to which they appear on Google. And all this data, well, it's analytical data, because logs data, for instance, is very specific to each customer. We cannot predict what field has to be present, what isn't. Every server has a different log file configuration. So we want to be able to expose all that and be able to express any SEO, so any business use case for us, using our platform. So here are some examples of what product pages are losing most traffic since my migration, what new keywords are trending and gaining most traffic compared to last time, what's the average loading time of my pages, for pages present in my sitemap and that are crawled. So some very, very business-specific use cases. And all these use cases are requiring to query one or multiple data sources. They're going to do different aggregations, different dimensions. So there's a huge flexibility on what we want to achieve. Also, once we are able to achieve all that, we want to be able to consume this data in any way. Okay, maybe in an application, our own web application, but a lot of customers for this types of analytics, they have their own tool already in place, a Power BI, a Tableau, a Looker, some data studios. So they also want to be able to explore the SEO data in these tools. We want to also have any export system, interactive APIs, a lot of different ways of how to consume all these different use cases. So we have a huge flexibility as input and a huge flexibility as output. And that's where the challenge is interesting. So we built what is called Botify Query Language, or BQL short. I won't dive into it, how it works specifically. We're going to talk a bit about the architecture and what's interesting about that. And I'll give you something to take home and to play around with. But the idea is that this is the input for an API query, for instance, but it's JSON that will define these use cases. You will define metrics, which will be aggregated by dimension. It's the basic usage of a data cube, of analytics data, is being able to aggregate metrics by some dimensions. Then you also specify what sources of data are needed, on what periods of time, how do I filter, how do I sort. All that's detailed on the website developers.botify.com, which you can visit if you want to learn more. But this is the basic idea of how we're trying to express these use cases. So let's talk about the architecture. How are we achieving that? What's interesting here? So the goal of this BQL is to be this interface, right? It's the eye of API. It's this interface between the data where it is stored, what we have on the right side here, on different databases, different backends. And we see there not only analytical databases, and how to consume the data, how in an application, in REST API, in some other tools and exports. We wanted this to be this interface that we own, and we have the ownership of how we're going to do things in between the consumption and the storage of data. So if we talk about what are the requirements we want here, so we want something very flexible to be able to express any use case. We want to be able to query the data from any possible backend, and we want to be able to respond in any possible format. So when this business requirements meet tech, it actually means that, okay, we're having this flexible input format, which we just saw this JSON, so we basically can define and put any fields that exist in our platform inside of the query and do whatever we want with them. For any backend, we'll have connectors, and we're going to have a smart logic about choosing what's the most efficient backend there. And then finally, we want to have some generic or adaptable export formats, right? So this is where it's interesting for such a tool, for such an interface that you own, because you're able to choose what's the right tool for the right job. Basically, there's not one size fits all in terms of databases. Every database is handling a different use case. As we just saw in the beginning, relational data against analytics data, but also a lot of other use cases. And so when you have all these possible use cases that you can express through one single interface, you need behind it to be able to optimize this so that it fits what's asked by the consumer. For instance, like the analytics databases, the data warehouses like BigQuery, Athena, Snowflake, they're nicely suited for aggregating some metric and on hundreds of gigabytes, terabytes in a very efficient manner. So there you can very nicely optimize these cases where you need to aggregate and have a real analytics use case. But since the API is so expressive and can be very flexible, you could also actually query very few rows and have more of a key value usage or a relational database that will match these use cases best. If, for instance, you will always access the most frequently accessed rows, maybe the pages on your website that are mostly visited, those are the ones that you want to retrieve often. So these may be cached, these may be in a key value store, so we don't need to parse all this data of an analytics database. And there are also cases, for instance, in our SEO case, where we crawl websites, we have the raw HTML of each page. This is pretty huge on most websites, having the raw HTML, and you need to compress it so the storage is not too expensive. So you won't fit that into a big query. That wouldn't make sense. It's not the right tool for the right job. It would cost you an arm. The performances would be horrible. It's just not the use case. So here is a nice aspect of we are able, through this one interface that we own, we're able to combine different backends to retrieve the data from where it's possible and where the data is available. So for instance, we want to have a case where we need to join multiple data sets, filter them, but also retrieve the raw HTML. Well, first we're going to do the query using SQL, and then fetch the data from our S3 object storage, for instance, and uncompress it, and return that to the data consumption layer. So that's the key part here is that you're able to optimize performances, querying costs, and storage costs, the three main aspects here which are important. So if you dive a little bit about how this works in theory, is that you have this JSON layer, this object, JSON object that is passed through the API. Then you have the schemas, which are defined internally to say, okay, these are different databases that we have. These are different fields that exist in there. They're available on this backend, on that backend. Both together will be parsed. We have an intermediate representation of the initial query, which will be called parsing information, where we'll know, okay, someone queried the average loading time on their entire website. And we know, okay, this data is both available on this database, so we're going to be able to query it there. So that's the job of the backend chooser, who's going to say, okay, here's the data, here's how I'm going to query it. And maybe it's going to be composed of multiple backends. And so it's going to create these transformers that will each handle a part of the query and maybe generate SQL queries if necessary and retrieve the data. And once we have the results, just a quick view on how we're going to export the data efficiently. Well, we need one component to orchestrate how data is exported. So maybe it's just in a raw API, HTTP response, or it's going to be some file export, or we're going to stream into customers' backend directly into their BigQuery table, for instance, so that they can consume it there. And this is all orchestrated by one transformer who will know the different backends, know how to export to them, and know how to format and compress data if necessary. So how about the lessons we learned when doing all of that? So first, obviously, since we're defining our own custom JSON DSL, so the domain-specific language of how it's working, onboarding gets pretty difficult, right? We're basically imposing to all API users to know this language and know how it works, what can you do, what cannot be done, since you all also have to have some safeguards. So there are a lot of concepts that one has to understand, and so the learning curve is pretty high. We dealt with that by basically having lots of trainings, internal trainings with the customers, that will be done by the developers ourselves inside of Botify, but also for the developers of our customers. We have documentation that we try to update, add many examples, and basically create a little community around that. Also, one interesting aspect is that, yes, we're defining a specific JSON API. However, we can also create a sub-dialect of SQL over this, so that dashboarding tools understand basically and can query this API through SQL. I mean, Data Studio, for example, Google Data Studio dashboard doesn't know how to write BQL. No one knows how to write our custom JSON. However, this dashboarding tool knows how to do an SQL statement. So if you can abstract that using SQL, you're directly able to leverage this knowledge of where do I query data using the dashboarding tool that any customer could have. And so we're currently working on having the sub-SQL statements that will then transform into a full BQL JSON query. Another challenge is obviously monitoring and tooling here. For the interactive API part, it's basically the only thing that will change when doing a request is the body of the query. It's always the same endpoint, so it's very important to know who is making what calls on these types of API. It's very important to understand what are the slow accesses, what are the expensive accesses, who is making these calls by combining which fields of your analytical data. Since you have this variety of backends that can be queried, it's very important to know exactly where the time is spent, what made us spend time there, since there is a choice logic that needs to be monitored. And so that's very important to have a fine-tuned monitoring on these types of things. So also, of course, breaking API changes, as usual, as always, is a touchy thing. At least with fine-grained monitoring, you're able to know exactly what is used, what types of fields are used, what are our API consumers actually doing as type of requests. Maybe some fields have never been used and we're able to break something, but everything has to be done very incrementally, since a lot of systems then depend on these types of API. When I go to a talk, I always want to end with something where I can go home and try it out myself. Today, unfortunately, BQL is proprietary, at least for now. But there's something very similar that exists, and which is open source, which is called Cube. Cube defines itself as the analytics API for building data applications. Basically, if you go to the website, you will see that they're pretty similar schemas as I just shown between the applications and the databases that you're going to query, and you have this interface in between them. And the query language is pretty similar. You see these measures, dimensions, filters. It's very near of what BQL is defining. It's also supporting multiple backends. It defines schemas just as BQL, so it's very similar in a lot of ways. The differences are subtle. those will really depend on our specific use case, where Cube is very generic and might fit a lot of needs. Our solution, since it's proprietary, it works very well for us today. But I really want you to try this out. I mean, I tried it and it works like a charm, so it's a really good thing to play with. If you have some time, go ahead with that. And that's about it for my talk today. To sum up quickly, well, how do you build an analytics API? It's all about understanding the data you have, since that's the most important things, and the flexibility you want to give then on how this data will be consumed and will be looked at and projected. This brings a lot of technical challenges about how do I optimize the costs and the performances on such a scale, because your analytics data is often very voluminous, and you definitely need to look out for that, so that you don't go bankrupt because of some crazy guys querying like no on your API. That's about it for my talk today. Thanks a lot for listening to it. Exactly 20 minutes, perfect. So thanks for listening, and do you have any questions?
Thanks a lot, David. While we're waiting for questions, please, people share your questions for David in the chat, and I'll pass them on. In the meantime, David, could you go back to the slide at the beginning where you give all of your contact details and some of your emails?
Yes,
where
of course.
Yep.
At the very beginning here.
Okay, yeah, fantastic. Some good links there for you for GitHub, for example, and the rest. So then I love how you've ended with giving the idea that you can actually, even though so Botify's got a proprietary code language, but if you wanted to, so it's almost like a way to sort of test out the capabilities of what Botify could do, but in an open source environment first.
Exactly.
Yeah.
Exactly.
Okay. Cool.
Ideally, we would like also to open source at some point, but when you didn't have open source in mind when designing, it's much harder to get there. So right. Cube is something to check out, definitely.
What sort of, so when you're making that decision about the cost of analytics being so high, if you log in everything, how are companies or businesses making those decisions about what they do want to log everything for, and what processes they're not logging? Is there any, like, you must log, are there any top, 1 or 2 use cases where you would definitely recommend that you should be using analytics and the analytics API to give you that observability?
Well, about logging the data first, the trend currently in the industry is to log everything. I mean, we saw that data is the new gold mine. If you have, the more data you have, the better you are off, even if you don't know what to do about this data. This type of analytics API is really about being able to leverage your data without necessarily only building on top of things that this one database you have your data in works. Basically, if you want to use it in an application and not only in dashboarding tools, that's where the API will be useful. I don't know if that answers the question somehow.
No, absolutely. I think that gives a hint to, the sorts of, because I think there is that limit there's a few limits with it. There's the limit of, like, by logging everything, there is a danger that you're inadvertently collecting GDPR data that you shouldn't be collecting, depending on whether or not you anonymize the user, some of those user login data fields.
Yeah, there's always this risk, for sure.
Yeah, and then also just the over time, the sheer storage costs. Like, it's enough to just have not cleared out your Gmails and suddenly need to start paying for it, let alone all of your login data. Okay,
that's where it's interesting to maybe split your data. Maybe every fresh data that you will access, maybe you're always dashboarding the last month of data. Maybe this put in a database that will be adequate, maybe cost a bit more, but more adequate to fetch this data. And the rest can be in a database that has a different access pattern, but maybe costs less because it's not there for live querying, for interactive usage. But that's the type of trade-off where you don't want to store everything in the same backend, because that cannot work for every use case you have.
That's really that. I mean, it goes back to your comments about backend. That's fantastic. That's really great insight. Okay, thanks so much. I'll invite you to leave the stage now, David. Great to have had you here.